All right, we're back. 8-3, the converse of the Pythagorean theorem. Now, if you look back to the last section, we said that in a right triangle, which in a way is saying if we have a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the legs. If we switch the if and then statements, we'll get the converse, 8-3, which says if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So we're just switching if and thens. Okay, so we have a triangle with c squared equals a squared plus b squared. We want to prove that ABC is a right triangle. The key steps will be with, first of all, we'll draw the triangle. Then we'll determine that d squared equals a squared plus b squared, which is Pythagorean theorem. We'll give, since we're given that c squared equals a squared plus b squared, and then c equals d by substitution, then we have by SSS, the two triangles are congruent. And if c is a right angle, then G has to also be a right angle, because the corresponding parts of congruent triangles are congruent. All right, so if we have a triangle that has a side of 3 units, 4 units, and 5 units long, that might be something like 3, 4 in this direction, and 5 in this direction. And we plug these numbers into a squared plus b squared equals c squared. If this is indeed true, then this is a right triangle. 9 plus 16, it really is 25. So therefore, we have a right triangle. So these numbers, the 3, 4, 5, are called a Pythagorean triple, which means they are whole numbers that form a right triangle. It's not always the case. There's only certain cases where that happens. And here's some of the common ones: 5, 12, and 13, 8, 15, and 17, 7, 24, and 25. And then you can also take multiples of each one of those to get other right triangle lengths. Okay, so we're going to look at theorems 8-4 and 8-5 along with 8-3. If you know the lengths of the side of a triangle, you can use these theorems to determine whether it's a right triangle, an acute triangle, or an obtuse triangle. So in each of these, the longest side of the triangle is C. And then, so in this case, if we have C squared is equal to a squared plus b squared, then that means the measure of angle C is 90 and ABC is a right triangle. That's the one we've already looked at. Now, if we calculate C squared and a squared and b squared, and it turns out that C squared is less than the sum of those, then that means the angle C up here is less than 90, so therefore it is an acute triangle. And then if C squared is greater than the sum of a squared plus b squared, then we know that angle C is greater than 90, and we have obtuse. So if we're given 3 side lengths, we can determine whether it's a right, acute, or obtuse. So for the first one, 9, 40, and 41, we put those in. We use C as the longest. C squared, 41 squared, equals 9 squared plus 40 squared. And that is correct. And we have a right triangle. So on the second one, 8 squared, compare that to 6 squared plus 7 squared. Well, as it turns out, C squared in this case is less than the sum of a squared plus b squared, so we have an acute. And then on the C part, C squared is bigger than the sum of the other two squares, and it's obtuse. So the classroom exercises in this section will deal with determining whether something is acute, right, or obtuse, or you could also have a situation where you can't even have a triangle that could be formed. That's another rule that wasn't specifically stated in this section, but when you have the sum of the sides of any two sides has to be greater than the third side. So with a 3, 4, 5, 3 plus 4, sum of any two has to be greater than the third side. 3 plus 5 has to be greater than 4, and 4 plus 5 has to be greater than 3. And all three of those conditions exist, so we do have a triangle. But if we had a triangle like 2, 3, 4, no, that one would actually work. 2, 3, 6. And now we have 2 plus 3. It's not greater than 6. So therefore, not a triangle. Okay, we'll take a look at those, do those classroom exercises and then the written exercises, and we'll move on to the next section.